Hi, today I'd like to actually show you currying in Swift because I know a lot of my viewers are Swift developers or iOS developers, so that's more useful for most of you since probably no one really knows Haskell or languages like that. Anyway, so we're going to start importing the foundation. I hope the font size is big enough. In my prior videos, I always had it on the standard that Xcode has. I believe it's 11 or 12, but now it's about 24. Since this isn't a presentation with like a beamer or whatever, this should do too. I hope, because for those kind of presentations you probably need something over 30. Alright, so as I said, we're going to look at currying today, and we'll use the example of contains. You may know this function if you, for instance, write an array like this, and you use the method called contains on that list on that array type. You can simply type in that element. So in this case, it's an int as the compiler infers, and we can now simply say 3 or 4, and it will say true. If I put in a number that doesn't exist, it will say false. Now, I don't really know how contains is defined in Swift. There's probably, I think it is an n step process, so it would mean that if your element happens to be at the last position, that's where it is. So I'll just assume that and work with that fact. Okay, we're going to define it by currying. So we'll start off by thinking about what the general, okay, I apparently can't delete it. Okay, there you go. So if we define it generally without currying, we would say contains. We're not going to make an array extension. We're just going to use functions here that are independent of the type, basically. I mean, we could simply do an array extension, as I said, but we're not. Okay, so it would look something like this. You would obviously give a list of any type, so we have to also define, so if you do it like that, I forgot. So you define it like this, right? And then here you have a list, then you need an element, which is of type T, and then you'll give back a bool. Now, as we've figured out in one of the prior videos, we do not have more than one input in currying. That's what we'd like to achieve. And we can do that easily by simply saying, well, let's have the list be supplied first, and then we put in an element, and then get back a bool. That's how we work around. That's a curried function so far. What's that saying? Oh yeah, sorry, you have to put around these. You have to put around put around parentheses here. I'm not quite sure why, but you do. Yeah. So what I'd like to do usually is simply remove these types by saying the label is none. There you go. What? Can you not do that? Oh, apparently you can't do that. Well, whatever. Okay, so, and what we have to do now is, since we return a function, we have to return. And what we can do then is open a body, and that's our scope for this function. Here we can say what we call that input parameter. Like that input, that parameter, we can give a name right here. So we'll call it element n. That's very useful because now we can say something like, let's think about that for a second. How do we define it? Well, we can say if our current element at the list, so that would be the first, if the first equals our element, or well, our element equals first, that we can say. But for that, we actually need to say this has to be comparable, I think, or equitable. I think comparable. Anyway, we'll see later. So we can say that. So if our current element, sorry, if our search element equals the current element, well, we are done and we can return true. However, if it's not, we can simply go down here. You can combine it with else if. I usually don't. So here we can say, well, if our list is, well, empty, if our the next step is empty, so we have to think about how to do that. I guess you can do that by saying drop first. I don't know how we can turn it into an array really. I'd do it like this, but I would think that's not very performant. But let's just go with that for now. So list drop first. So we have drop the first, so that's the list afterwards, and it can be empty. So we can say it's empty. And that should return, then we should say return false because we can't compare anything anymore, and it's okay. So we apparently have to put parentheses around this, I guess. Yep, and then here, what we can do is, well, we can say return false. Actually, let's do it like this. We can say return false, and in case that never is the, in case that's never the case, basically. So, I know, not never. If our following list is not empty, then we're going to do something else. What we're going to do is we're going to say let me run an extension really quick. Array get tail. I think that would be quite pleasant to have. Element. Then we can simply say return self dot drop first map, and there you go. That should do the trick. Yeah, sorry. That's an array. If I say list, I mean array. I'm just very used to Haskell. I should care about that. I'm sorry. So there you go. Now that makes it easier for us to write this. You can simply say list get tail is empty. Well, it's not empty basically. And then here return. Here we can return contains. Then our list, which is the one that's the tail, and then supply our element again. And the rest is false. And that's it. That should work. And it does. And now we can check if it works. So we can say contains, so we say that, and we can say 1. That should say true. You see it's not very performant. True. 5. Let's say 0. And 6. Let's see if that works. Yes. So there you go. That worked fine. We have our contains method, or well, function in this case. That's a method. That's not. So we have our function contains, and we declared it in currying. And I think another example that we could work on is the modulus function. That would be interesting too, though I didn't really plan on doing that, but let's just do that. Mod. So we're going to say mod, and well, if you don't remember what it looks like this. So if we say 25 modulus 5, that will give us 0. Let's comment all of that out, basically. There you go. So that will give us 0. Sorry, 0. And if I say 25 modulus 4, that will give us 1, I believe. Yeah. So it basically just gives you the rest. In Germany, we say that's elementary school division, because that's how you learn it at the start. I think a lot of people do around the world too. So that's elementary school division for you, modulus. It's useful a lot of the times in programming, so maybe defining it by using currying, or currying that function or that method. You could also write a infix operator if you'd like to, but we're just going to do that as a function. That's probably very interesting. So we're going to say mod, and that will take, again, a number. So we can say for instance, t equatable, well, numeric and comparable. And then we can say, well, n is going to be like of t. And then we have a second number, and then we'll return, well, we learned we don't have to do that. And then here we have a second number, and then we'll get back a result. So you see, there's a pattern. If you were to have more functions here, you could simply write, again, another function, and you have this kind of thing, but we don't. So that's okay. All right, let's see what we can do. So how would that work? So if we write down, for instance, 25 and this, how would that look like? That would look like this: 25 minus 5. Or let's actually work with 4. 4. So that would be 21. Then here 21, 4. That would be 17, and you get the point. So let's just write that down. It looks like this: 39 minus 4 is 5, and then 9 minus 5 minus 4 is 1. So, and then we can't really do it anymore because we're staying in the positive numbers. Okay, so that's how it works. So we see we always subtract the number to the right of the operator. And as soon as the current number, when it's subtracted again, is if you can't subtract the number to the right anymore in a positive range, that means you're done. Okay, so let's try and replicate that. Basically, we're going to say, we'll return again, obviously, number 2, and you can write that as you'd like. I mean, the formatting, considering the formatting. So we can say, generally, we're going to do, well, we're going to say mod, and then, obviously, n minus n2, and then n2 again. That's our general idea. But if n minus n2, if n minus n2 is smaller than n2, n2, that means you'd just return n minus n2 because you're pretty much done, and otherwise you're going to always call this. Yeah. See? Oh, that's not a number type now. I don't know what is it. Isn't it numeric? I haven't worked with Swift in so long. I don't really know if it's numeric. Well, you get the point. You could simply write that generically, but let's just use double for the sake of being able to do this. There you go. See, that should work. We can check on it by it's running. I don't know what it's doing. Okay, it seems like it's done. So if we do that, that should give us 0. Let's see if that's true. 0. Let's do 4. That should give us 1. There you go. Cool, it works. Now that's done using currying, or well, that's a curried function, and that is a curried function as well. And we're done. I hope you get the idea. You can do that in a lot of programming languages. It's very interesting because in Haskell, for instance, that would be a lambda expression. I don't think, or well, an anonymous function, but I think in Swift, you wouldn't really call it a lambda, right? At least I'm not very sure. It doesn't look like one at all, but it sort of replicates it. All right, so thanks for watching. I hope you learned something, and goodbye.